So hello everyone. Please let me know whether I am audible and visible. Further we will proceed the chapter. Let me confirm by my own phone. Guys, whether you are revising it or not, we already have finished the chapter motion and force. हम लोग मोशन और फोर्स चैप्टर खत्म कर चुके हैं पूरे इंड तक. पूरा होल कॉन्सेप्ट हम लोग देखे, उसका फिर सर्कुलम का क्वेश्चन सॉल्व किए. इसके बाद भी अगर आप लोगों को कहीं पे डाउट और प्रॉब्लम इस चैप्टर में है तो प्लीज़ कमेंट इन द चैट बॉक्स. और अगर आप लोग नए हैं तो प्लीज़ सब्सक्राइब कीजिए चैनल को फॉर फर्दर अपडेट्स. And also if you have still any doubt in the motion and force chapter, you can also put a message in WhatsApp group or Telegram community. That's all. Now we are in chapter pressure. So what we have studied in previous class, let me recall first, then we will further proceed. So in previous class we have studied about what is pressures. Let me share the note of previous class. Okay, we have note. So is it visible, guys? Let me share. I didn't share the. Okay, is it visible, guys? Please let me know. Is it visible? Okay, we have what we have studied in previous class. Let me recall in short, then we will further proceed. Okay, pressure chapter start from here. Okay, in day one we have studied how pressures coming out of pipe or due to pressure, how, let me zoom it. How pressures, pressure of brick uh, applied on foam to make a crest downward in the foam, and how the pressure of atmosphere holding the upward, holding the cardboard in upward direction, uh, which is above, which is below the glass filled with water, which is not coming out due to the pressure. So we have seen the example in previous class, and we defined the pressures. How pressure is defined? Pressure is the force which act perpendicular to the surface of an object is called thrust. First of all, the thrust, how we defined in simple word: force acting per unit, force acting perpendicular to the surface. Anything, let's say this force is perpendicular to the surface, then we can say the thrust is acting upon it. And SI unit is Newton. It is same as the force, that is Newton. And also we define the pressure in simple word as pressure is the thrust per unit area of object, and the SI unit of pressure is Newton per meter square. We have also seen activities and examples in balloon, how pressure is applied in balloon which is holding below the water, and how the balloon filled with H2 gas we have seen in fear moving upward when the force and pressure which is applied on the balloon, and at some time it is equal to the weight. Pressure exert a force on the balloon, and when that force become at some time equal to its weight, then it will not move further. Also we have seen the pressure transmission in the syringes and that's all. Now we have in class day 2. Let me use the other pen. Okay, we will use this pen. Okay, but this is not good. Use this. Maybe this pen. So we are in day 2 class. This is fine. Okay, this is visible. So today date is and 17/8/2024. So guys, we are moving with calculated with all calculation of time. When will be the chapter finish? When will be the course finish? We have a proper roadmap. So according to that, we will revise it very well for the board, and how we will prepare for competitive exam. We have a problem solving day as 2 in which we are solving questions. Okay, is there any chat? I not able to see in the previous chat. So some students are telling that, sir, you are not seeing the chat. Okay. Okay, now we have moving forward to the chapter pressure and pressure. So now we have first of all, first we describe the Pascal law. We have continue with the topic Pascal law. So if anyone studied Pascal law, please comment in the chat box if you can. Okay. We have seen the transmission of pressures in syringes, and we have also seen in the balloon how balloon bump up when we uh, uh, squeeze with our hand. So now we have an activity. First of all, we will understand Pascal law with the activity. So we have a also I mentioned, I earlier mentioned also, and now I am also telling that we are following circulum book for the concept, and other than this book, if you have any doubt or any query or any problem regarding concept or any numericals questions, so you can put in the chat box or WhatsApp or Telegram anywhere, so we can solve your doubts and query as soon as possible. And now we have Pascal law. So we have a polythene bag full of water. Let's say this is the polythene bag. In this we have water, full of water, and this polythene bag, PULYTHENE. I don't go with my spelling, guys. This, I think it is polythene. It is polythene bag. तो हमारे पास एक पॉलीथीन बैग है वाटर जिसमें भरा हुआ है, और हमें बोला गया है कि squeeze the bag from the top with a fist and make a fine holes around it and observe the water coming out of this hole. हम लोग को अपने हाथों से, एक सेकेंड, हम लोग को होल्ड करना है, अपने फिस्ट से स्क्वीज करना है और एक होल्स करना है पॉलीथीन बैग में। तो और ऑब्जर्व करना है कि कैसे कैसे वाटर होल से निकल रहे हैं। तो ये एक्टिविटी के हेल्प से हम लोग पास्कल लॉ समझेंगे। तो सबसे पहले ये एक्टिविटी में हम लोग को बोला गया है कि एक पॉलीथीन बैग लेना है जिसमें छोटा छोटा स्मॉल होल्स करना है और हम अपने हाथ फिस्ट से स्क्वीज करेंगे पॉलीथीन बैग को और ऑब्जर्व करेंगे कि किस स्पीड से वाटर होल्स से निकल रहा है। ओके, दिस इज फिस्ट, don't go on my drawing guys. So this is fished. So we will squeeze this polythene bag, and it is telling that does the water coming out from all holes uniformly. और ऑब्जर्व करेंगे कि कुछ होल्स यहाँ पे भी होंगे, कुछ होल्स यहाँ पे भी होंगे, कुछ होल्स यहाँ पे भी होंगे। तो हम लोग को ऑब्जर्व करना है कि सारे होल्स से पानी एक ही स्पीड से निकल रहा है या कुछ डिफरेंट स्पीड से निकल रहा है। यहाँ का स्पीड, यहाँ का कुछ स्पीड, यहाँ का कुछ स्पीड होगा। तो हम लोग को बोला गया कि सारा स्पीड सेम होगा या फिर दूसरा होगा, तो क्या होगा। तो बोला गया ऐसा कि when the fist is tightened, the pressure generated in the water at the upper part of the polythene bag is transmitted through the water on the walls of the bag. ये जाहिर सी बात है, हम लोग पिछले के एक्टिविटी में देखे थे कि जब कोई बैलून को हम अपने हाथों से स्क्वीज करते हैं तो वो कहीं कहीं बम्प हो जाता है और अपने जो हाथ में रहते हैं उसको श्रिंक हो जाता है और जो बाहर वाला पार्ट है वो थोड़ा बम्प अप हो जाता है। वो हम लोग पिछले एक्टिविटी में देखे थे। जस्ट लाइक ऐसा पॉलीथीन को भी जब अपने फिस्ट से स्क्वीज करेंगे तो ये कहीं ना कहीं प्रेशर लगाएगा पॉलीथीन बैग के वॉल पे। तो वो प्रेशर्स के कारण ये होल्स से वाटर बाहर आएंगे। तो वो जो होल्स है वो सारे होल से स्पीड ऑफ जो वाटर कमिंग आउट होगा, जो बाहर आएगा, तो वो सारा का स्पीड सेम होगा या डिफरेंट होगा, ये हम लोग को ऑब्जर्व करना है। और होगा तो ऐसा क्यों होता है ये, तो हम लोग को बोला गया ऐसा कि the pressure generated at a point in the water enclosed inside the polythene bag is transmitted normally in all directions. Okay. तो प्रेशर जो होगा तो वो तो एक क्लोज्ड कंटेनर जैसा बिहेव करेगा फर्स्ट ऑफ ऑल। तो वो प्रेशर जो लगाएगा पॉलीथीन बैग पे वो परपेंडिकुलर होगा सरफेस पे पॉलीथीन बैग के, जो कि हमेशा नॉर्मली एक्ट करेगा, मींस परपेंडिकुलरली एक्ट करेगा। तो ऐसा हम लोग मान लिए। तो और आगे हमारा दिया गया कि फ्रेंच मैथमेटिशियन ब्लेस पास्कल pronounced a law about this in 1653 BC is known as Pascal law. तो यही लॉ जो बोला गया कि नॉर्मली होगा, जो सरफेस इनक्लोज इनसाइड द पॉलीथीन बैग इज ट्रांसमिटेड नॉर्मली इन ऑल डायरेक्शन। तो यही जो लॉ एक साइंटिस्ट थे, महान साइंटिस्ट ब्लेस पास्कल, ये प्रोनाउंस किए लॉ को पास्कल लॉ के नाम से। So this law states that when a force is exerted at a point in an enclosed liquid, the pressure generated is transmitted normally throughout the liquid in all directions. Just like यहाँ पे हम लोग फिस्ट से स्क्वीज किए तो यहाँ पे कुछ फोर्स एक्सर्ट हुआ, ये क्लोज कंटेनर या फिर कोई क्लोज्ड ऑब्जेक्ट के अंदर, तो ये नॉर्मली एक्ट होगा ये सरफेस पे पॉलीथीन बैग यहाँ पे परपेंडिकुलर होगा इसके हिसाब से, यहाँ पे परपेंडिकुलर नॉर्मली मींस नॉर्मली। So this law states when a force is exerted at a point in an enclosed liquid, the pressure generated is transmitted normally throughout the liquid in all directions. That's we are telling. For the verification of Pascal law, we have taken just a 4-bay, just like 4-bay pipe systems. Okay, we will draw it deliberately. So we have just 4-bay, just like 4-way pathway of pipe system. So this F2, this F1, and this one is F3, and this one is F4. This is A, this is B, this is C, and this is D. So here we have also we can conclude A1. This is just like a scope, and let's say we have another full of water, and here is the piston we have. We apply 10 Pascal. Then what will be the pressure at here, pressure at here, pressure at here? First of all, we will verify the Pascal law in a circular vessel which have 4 piston. Okay, A, B, C, D. That is A, B, C, and D. A, B, C, and D. Now it is telling that suppose the cross-sectional area of 4 piston is A1, A2, A3, and A4. We have this is A1, A1, A2, A3, and A4. We have the cross-sectional area of all pistons we have. When a vessel filled with liquid is pushed inward by applying a force F1 onto a piston, piston A, and the pressure generated on the cross-sectional area of the piston due to this pressure, remaining 3 piston move outward. This means the pressure generated at the piston A is transmitted normally throughout the liquid. The inward force applied to the outward moving piston to prevent them from moving, the F2, F3, F4 respectively, the flowing result is obtained. Okay. When we applied a 10 Pascal unit at piston A, let's say B, whatever you can take. Then the rate, when we applied a force on the piston A, then it will exert a pressure. So this pressure will result in acting normally to the all in all direction of the pipe or vessel. So here we see it is also coming out with 10 pascal. It is also coming out with 10 pascals. It is also coming out with 10 pascal. So we can conclude that the pressure exerted in the vessel is normal in all direction by this observation, because here it is also acting upward with 10 pascal, it is also moving left with 10 pascal, it is also moving downward with 10 pascal. So it is normal na? In all direction it is coming out with same, and it is where it is open it is coming out with perpendicular pressure. We can also conclude that, let's say we have a phone applied across this and in this piston, which is equal to f2, also equal to f3, also equal to f4. It is coming out with same force. So we can also conclude that no, we can write it as sorry, the pressure with which it is coming out is same. So pressure is nothing but what we have defined, force per unit area. So we have cross sectional area as A1, A2 and A3 and A4. We have earlier defined that. So the pressure is equal all over the uh, all over the all surface in the liquid vessels normally. Therefore, the pressure generated at one point in a liquid kept in a closed vessel is transmitted equally everywhere. We can conclude that this important point. Therefore, please note it down. Therefore, the pressure generated at one point in a liquid of closed vessel or we can in a closed we can definitely that in a closed vessel is transmitted equally everywhere. We can conclude from this activity and observation. So we can we just observe. So what is the use of Pascal law? If anything, we cannot relate with real life. It is not interesting, not whatever it is has no meaning. जब तक हम लोग अपने रियल लाइफ से कनेक्ट नहीं कर पाएंगे कोई भी चीज को, तो ये हमारे लिए थोड़ा अजीब ही, मतलब अच्छा इंटरेस्टिंग नहीं लगता है. तो हम लोग ऐसा एप्लीकेशन ऑफ पास्कल लॉ समझेंगे कि what are the application of Pascal law. Based on Pascal law, various type of hydraulic machines such as hydraulic brakes, hydraulic lifts, hydraulic presses, etc. are manufactured. हम लोग एक हम ऐसा जहां तक देखे हैं, एक जब कार को कहीं पे लिफ्ट करने में जैसे कि यहाँ पे लिक्विड फिल्ड विथ वाटर होता है और यहाँ पे एक पिस्टन है, यहाँ पे कार को लिफ्ट करने के लिए प्रेशर का यूज करेंगे. जैसे कि हम This is car, and it is over the piston, and it is connected with the liquid. It is filled with, and here it is also piston, and here it is water. When a piston, when there is pressure is applied, it will get lift up. So this will be the application. We also have hydraulic brakes, hydraulic lifts, and hydraulic press of real of Pascal law, application of Pascal law. First, we will understand with hydraulic machine. Hydraulic machine, application of Pascal law. So first we have to take two syringes with different thickness and saline pipe and a butter in it. Connect the mouth of syringe with saline pipe as shown in the figure. Guys, if you have a circulum book, please take it with you, because we have as many time told, we will follow the circulum book first of all for the concept, because it will be the basic book for the boards, and we will further also go with the competitive questions. So if you have other book you doubts, doubts in other books or other sources, you can comment in the chat box. For now, just see all laugh. It is saying hi sir. Okay, hi, just see all laugh. Now we will see the hydraulic machine first of all. So in the figure, let me make a figure first of all. Okay, first let me, if I can take an image and I will show, then I can. Okay, first it is. Let me copy and paste the image. Is it visible, guys? Now what it is going? Now it is visible. Okay. How can I copy and paste the image? Let me see how it is. I can copy and paste the. Okay. Okay. So this is basically the two pipe. One is a small it is connected with the rubber tube, and we have a small piston and a small syringe. Also, we have a large piston of bigger syringe, and it has larger piston, and it is connected with the rubber tube containing saline water. And so pull the piston of a syringe and fill it with water. Okay, we have to pull the, first of all we will pull the syringe, piston of the syringe, and fill it with water. While filling the water, the barrel of syringe should be filled with little more halfway, leaving the space for the piston move outward. ओके, हम लोग पूरा फुल नहीं करेंगे, लिटिल मोर हाफ वे तक हम फिल करेंगे, थोड़ा स्पेस छोड़ेंगे पिस्टन टू मूव आउटवर्ड होने के लिए. तो इफ द वेट इज प्लेस्ड on the top of a small piston, so this is a small piston. तो ऐसा बोला जा रहा है कि अगर हम कुछ वेट अप्लाई करेंगे पिस्टन के ऊपर, छोटे सिरिंज वाले, छोटे पिस्टन वाले यानी स्मॉल सिरिंज में, तो ऐसा an object with a heavier weight is placed on the other side of the piston, will the heavier object be lifted. तो जो छोटा ये बड़ा वाला सिरिंज का पिस्टन है, ऐसा लिफ्ट होगा कि नहीं, ऐसा हम लोग को कंक्लूड करना है. तो एक हम लोग टेबल बनाएंगे और रिजल्ट को ऑब्जर्व करेंगे. When the weight on the top of larger piston increases, become equal to the maximum weight that can lift by the small piston. So ये जब weight, ऐसा बोला जा रहा है कि when the weight on the top of larger piston increases and become equal to the maximum weight that can be lifted by the small piston. तो जितना weight ये larger piston लगाएगा, वो जब स्मॉलर पिस्टन के जितना वेट के इक्वल हो जाए, या फिर जितना ये लगा सकता है वो उसके इक्वल हो जाए, तो पूछा जा रहा है कि small both the piston remain in balanced condition, और what is the weight necessary for that. अगर ये पिस्टन हमारा है, ये फोर्स लगाएगा, तो ये कितना वेट मैक्सिमम होल्ड कर पाएगा, जितना ये फोर्स लगाया जा रहा है छोटे वाले पिस्टन पे, और जितना ये वेट होल्ड कर सकता है बड़ा वाला पिस्टन, उस कंडीशन पे तो एक इक्वल होगा. और पूछा जा रहा है कि व्हाट इज द वेट नेसेसरी फॉर दैट. डाटा टू बी tabulated in the table similar to one of the shown below. Okay, we will make a table. First of all, let me write tabular format. So the weight placed on the smaller piston F is F1, and we have the weight placed larger piston is F2. कुछ वेट हम लोग को पहले से दिया गया है, F1 एंड F2, और रिजल्ट हम लोग को कंक्लूड करना है कि क्या होगा, किस कंडीशन पे, डिफरेंट कंडीशन पे क्या रिजल्ट हम लोग ऑब्जर्व कर पा रहे हैं. बस ये टेबुलर फॉर्मेट में हम लोग को बनाना है, ऑब्जर्व करना है रिजल्ट के वाले रो में. तो क्या होगा गाइस, इफ यू कैन just one column will be enough for the अंडरस्टैंडिंग. ये हमारा सिरिंज था, छोटा वाला सिरिंज, और इसमें F1 अप्लाई किया जाए, इस पे F2 अप्लाई किया, बेट है हमारा सबसे पहले. तो डिफरेंट डिफरेंट फोर्स पे हम लोग को ये निकालना है. तो ये एक्टिविटी as we can see in our homes, or you can try it by your own. We don't have bait right now, so we can observe with the, we we will not able to calculate. So the now we have a hydraulic machine. It's a force multiplying device based on the Pascal law. So we have seen the we have some seen in the just like videos. We have to make a hydraulic. Let me you have seen the JCB's structures. It has a just like hand like a structure, and this in the upper part there is one for moving and lifting up. There is one machine known as hydraulic. So how it works we will observe now. This is hydraulic. So it is given there. The hydraulic machine is a force multiplying device based on the Pascal law. The excavator or backbone shown in the figure, as I also draw there. The hydraulic cylinder of a piston are used to move the digging part. While digging the ground, the upper part of the machine should be bent back toward the ground along with the backhoe, so that the backhoe sinks into the ground. For the shown in the diagram above, the fluid in the black colored flexible pipe is pushed with the help of piston, and as a result the force exerted by the driver from a small piston magnifies and the ground is digged. And let me put the picture in the notes. Okay, we have, it is so this is basically our what hydraulic machine we can say. Just was I want to see this black colored object filled with fluid. Because of this fluid, this backhoe able to sink in the ground, and due to this pressure applied by this fluid, black object filled with fluid, it is able to dig the ground. This will apply pressure in downward direction, and this will help to move downward, and this backhoe will dig the ground. This is all because of the pressure applied on the backhoe. just I want to say that the what the pressure can do. So one of the example is hydraulic machine. How hydraulic machine able to dig because this will exert pressure and this pressure will move this in ground, and when this will exert a pressure on this uh, जब ये प्रेशर लगाएगा तो ये वाला जो पार्ट है ये नीचे जाएगा, और जब ये वाला प्रेशर लगाएगा तो ये ग्राउंड को डिग करेगा. एंड दैट्स ऑल अबाउट हाइड्रोलिक मशीन. Construction and working mechanism of hydraulic machine. We will now see the how. uh, I think this is enough for today. We will move with the topic construction and working mechanism of hydraulic machine in the next class. So what we have studied in today class, we have seen Pascal law, how Pascal law is how Pascal derived, how Pascal defined the pressure in the liquid is normal to the surface of closed vessel. And we have seen the application of Pascal law. The first one is hydraulic machine. We have also seen the one activity, the weight applied on the syringes of different piston. And also we have seen the how hydraulic machine dig the ground. And further we will discuss the mechanism of hydraulic machine in the next class. See guys, we are moving in moving with slow speed because we know we have all things calculated. We have all the we have all roadmap to for revision, for problem solving, for concept. We have all calculated it, and then we are moving further. So we have enough time. So make patience till the course end. And till now, if you are not subscribed the channel, please subscribe it and stay connected. Till then, keep learning and keep exploring.